So, hello everyone. Today we are going to discuss about spin locks in device drivers. Spin lock is the most famous, most popularly used, most common, and one of the most important inter-process synchronization mechanisms in device drivers rather. Now, spin lock involves synchronizing those kind of applications that cannot go to sleep. Most locking is implemented with a mechanism called a spin lock. It is used in code that cannot sleep. Till now, we have seen synchronization using semaphores and using completion. In both semaphores and completion, there is an issue that when the process is not able to get into the critical region, then the process go to sleep in the either the semaphore wait list or the scheduler's wait list only. Okay, but in completion, that sleeping is not allowed. When the process is able to get into the critical region, then it's fine, it will get into the critical region as usual. But if the process is not able to get into the critical region, then the process will not go to sleep. Instead, the process will behave like this. Suppose this is the critical region of code, and a process comes here and tries to get the spin lock, just similar to way it tried to get the semaphore, it tried to get the spin lock. Similarly, the process tries to get the spin lock, the way it tried to get the completion, and the process is able to get the spin lock, and process proceeds further in execution in critical region of code. This is suppose critical region. And process executes in the critical region. While the process was executing in the critical region, suppose another process came in and tries to get into the critical region and tries to get the spin lock, but it sees that the spin lock has already been taken by some other process, and the other process has gone into its critical region, and the other process is executing in its critical region. Then, normal circumstances, using semaphore or using spin lock, this process would have gone to the waiting list, but in spin lock it doesn't go to waiting list because sleeping is not allowed. So what it will do is it will spin, check, 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 check. Sometime a time will come when it will get the spin lock, and then it will proceed in the execution in the critical region. If another process also comes, the another process also comes and sees that the spin lock has already been taken by some other process. So this process will also go into a very tight spin where it will check, 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 and keep on checking until it gets the spin lock. Okay. Now, an important thing. When the process tests the semaphore for a variable lock or unlock, if unlocked, then it will lock it and proceed further in the critical region. The process, the spin lock, is either locked or unlocked. Okay. If unlocked, then the process can lock it and go into critical region. Okay. Now suppose one process is executing in the critical region. At that point, another process arrives. If the process finds that the critical region, that the spin lock is locked. Means somebody else is executing the critical region. Means some other process is already executing in critical region. In this case, the new process has to wait to enter into the critical region. So the new process has to wait to get into its critical region for execution. But the wait is not sleep. This wait is wait, not sleep. Okay. In the spin lock, sleeping is not allowed. Okay. So as an important point, sleeping is not allowed. बता रहा हूँ, sleeping is not allowed, and the process will not go to wait list. Okay, instead we'll go into a tight spin. Now the spin part is non-interruptible. Okay, non-preemptible. Non-interruptible, non-preemptible. Atomic mode of execution. This spin part. When the process goes into spin on the spin lock, that spin part will be non-interruptible, non-preemptible, non-atomic mode. Atomic mode means a process goes into spin, it will spin forever unless it gets the spin lock. And nobody can stop the spin. It will spin and spin and spin unless you get the spin lock. It is non-interruptible. Nobody can interrupt it. Okay. You give control C or whatever way you try to stop the process, it will not stop now. It will run. And on a unicore processor, if there is only single core, then the single core will go into a hang, absolute hang, until unless it gets the spin lock and gets into the critical region, it will be in the hang state. Okay, this is spin lock. Not only that, not only that, when the process enters into the critical region, then the execution in the critical region is also non-interruptible, non-preemptible atomic mode of execution. Means if the process goes into test on the spin lock, then it will start spinning, check, 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 check if the spin lock is locked. And that check portion, spinning portion, is non-interruptible. You can't interrupt it, can't stop it. Non-preemptible, you can't terminate it. Atomic mode of execution means nothing will execute on the system, only this will execute. And then when it gets the lock and it gets into the critical region, then the execution in the critical region is also non-interruptible, non-preemptible, atomic mode. Non-interruptible means can't interrupt it, pause it. Non-preemptible means you cannot terminate it. Atomic mode means all the executions will happen at once. Okay, this is the special ability property of the spin lock. And a spin lock is primarily implemented for synchronization in those code which are not allowed to sleep. See, I'm removing my headphone. If you will have any doubt, you'll ask me. You'll send me a question mark, then I'll connect back. Okay, so spin lock. Now the spin lock will go into non-interruptible, non-preemptible and atomic mode of execution. So what is non-interruptible? I'll come to that. I'll tell you that. There is another question that you've asked that is also pending. So non-interruptible. Means it can not be paused, sleep, or put into any wait list. Okay, non-interruptible. Then non-preemptible. Non-preemptible means the process cannot be terminated okay. Then you have atomic mode. Means all statements and operation will happen as one unit without any break. Any break in time. Okay. अब बात करते हैं नॉन इंटरप्टेबल की, विच इज इन ब्लू. The interrupts could be disabled on current core of CPU only or all the cores. ओके, हो सकता है कि आप एक ही कोर पे इंटरप्ट्स को डिसेबल करो या सारे कोर्स पे. आई सेड इट इज नॉन इंटरप्टेबल. नॉन इंटरप्टेबल मतलब इंटरप्ट नहीं आएगा. इंटरप्ट विल नॉट कम. Interrupt will not come means interrupts are disabled. Now there are two choices how you can disable interrupts. You can disable interrupt on the current core of the CPU, or you can disable interrupt on all the cores of CPU. Okay. Then we call about non-interruptible. It applies also again the same. The interruption in the preemption is again different categories. Preemption involves different categories of interrupts. Preemption involves different categories of interrupts. That terminate the process. Okay, so these kind of interrupts could be disabled. These could be disabled on current core or all cores of CPU. This is configurable and I'll tell you how to configure it. Now coming to this atomic mode of execution. To make a process execute in atomic mode. खुला ही नहीं. We need to disable scheduling. We need to disable scheduling. Okay, on current core or all cores to make the process execute in atomic mode. तो आपको स्लीप, प्रीएम्पशन, इंटरप्शन और एटॉमिसिटी ये सब कैसे होती है बता दी. Jagjit, your first question is answered. Now you can ask me your second question. No, wait. Hold on. Yeah, tell me. When a process moves to wait queue, then it will not be scheduled with the processor, it will not be allocated with the processor, and therefore it will never execute. Yeah, awaken means move back to the run queue. Okay. चलो. नहीं चल पाएंगे. When your spinlock is program holds the spinlock and runs. Then no other process can run because scheduler is disabled. Any other process cannot be allocated with the processor. Only and only that process holding the spin lock will run as the owner of the current core of the CPU, and no other process will run on that core of the CPU. Spinlock may offer very high performance than semaphores or completion in general, but they bring some set of constraints because they occupy the whole processor core. So Spinlock is called the mutual exclusion device because it gets mutually exclusive access to all the resources on the current core of the CPU. It is implemented as a single bit in the integer value. Like in semaphore, you had a semaphore variable. Like in completion, you have a completion variable. Similarly, in the spinlock also you have a spinlock that is called lock. It's an integer value 32-bit, but only one single bit, the LSB of that integer is used, which is 0 for lock, 1 for unlocked. Any code wishing to take out the particular test, the relevant bit, if the bit is a 1, that is unlocked, then it locks it, makes it 0 and goes into the critical region. If the lock is available, the lock bit is set and the code continues in the critical section. If instead the lock has been taken by somebody else and spinlock is already locked, when your process arrives at the spinlock, then the code goes into a very tight loop, spin check, where it repeatedly checks the lock until the lock becomes available, and this spin portion is non-interruptible, non-preemptible atomic mode spin. The spin is the spin part of the spinlock name. The test and set. Test, if not locked, then locked, means set. Operation must be done in an atomic manner. Well, this is a very strong statement. When a process performs a test, listen this carefully and understand this. When a process performs a test, then the process that performs test should get an opportunity. Good morning, Shika. The process that performs test should get opportunity to set it also or reset it also. Until unless the process that performs a test is able to set or reset, no other process is allowed to test. Okay, I hope you understand these two statements which I gave just now. Otherwise, you can ask me, I can explain this to you later again. Test as in whether it is locked or unlocked. Jagji. No, your question is not right. Your question should have been put like this, that the spinlock is working at the process level or thread level. Care must also be taken to avoid deadlocks on hyper-threaded processes. So it may be possible that some threads are holding some resources which are needed for some other threads, and other threads are trying to get into the spinlock. They will need to use those resources in the critical region, but those resources are not available, held by somebody else. So these are called, very deadly deadlocks. So we need to take care of this. So the actual spinlock implementation is different for every architecture that Linux supports. I'll come back to this point. Yeah, who is that? Some doubts? I said that I'll do that later. So the actual implementation is different for every architecture. This is another very confusing statement. I am explaining you spinlock right now. Now I am explaining you how the spinlocks is working on x86. This is x86 architecture I am working on. But when you work on another processor architecture like ARM, MIPS, PowerPC, Tiger Shark, Freescale, then on different architecture, the behavior of spinlock is different. It is not standardized. So you will have to refer to the documentation to understand the spinlock for that particular given architecture. I'll explain you for one architecture. Because you will understand for one architecture, you will know how to understand it for other architectures. Okay. Spinlocks are intended for use on a multi-processor systems. It should not be used on a unicore uniprocessor system, because on a uniprocessor system, if the process ever goes into spin, it will spin forever and nobody will be able to bring it out. A uniprocessor workstation running on a preemptive kernel behaves like SMP and is not advisable to use spinlocks there. If a non-preemptive uniprocessor system ever went into a spin on a lock, it would spin forever and nobody will be able to bring it out. Now it will spin because it is not able to get into the critical region. It is not able to get into the critical region, and not to get into the critical region, certain state has to be changed. But because it is a uniprocessor system, so the current spinning process would have taken the whole processor, and nobody else will execute. As nobody else will execute, therefore the condition state will never change, and the spin lock will never be unlocked. Synchronous multiprocessor machines. That's a architecture. We'll see that in project 9. Now to implement spinlock, what do? You implement spinlocks like this. Very first thing. If there are 4 processes, I'll tell you. If there are 4 processes running, means one process must be in the critical section holding a spinlock lock, and other 3 must be spinning on 3 other cores of the CPU for all the 4. Therefore, all the 4 cores are occupied. That the 5th one you're talking about will never get chance to execute because the scheduler is disabled. So there is no chance of having the 5th process running in a system where all the other 4 cores are busy taking care of a spin lock. That 5th process will never be able to run. Unless some core is available. It will not start at all. Scheduler is disabled. Who will start it? It ends up like that actually. Yeah, Jagjit, you were saying something? आप जो लैपटॉप आपने खरीदा है ना, the laptop that you have purchased a few days back works on the same principle. That there are spin locks implemented in your machine. OS, right? Yeah, on that core it runs very fast. It does give a very good performance. It does give very good performance. It actually gives very good performance. See, you can think like that. You can think like that it is jamming. But after all, what is jamming? Why not jam? The rest of the processes are not doing anything. The only process that is supposed to execute and do some task currently should get access to the processor, and it gets it the way it wants. So it's not jamming. It's actually using the all the resources to very fast way. Yes. Not sometimes, every time. Actually, I've seen people somehow end up implementing spin locks, and then after implementing spin lock, they start scratching their head and jumping from their window out onto the streets because it makes their life as hell. Because the system and the network and the protocol, everything starts hanging. When I used to work, I used to make people jump out of the window. But since I started training now, I try to shut every such window for my trainees. Spin lock. Declare spin lock in struct dev. In header declaration strategy. Okay. After that, go to init.c. In init.c, you will initialize your spin lock like this. Spin lock init. Okay, which takes the spin lock and initializes it. Look at this in the code which is used here, spin lock init. The example, this is the example one, and this is the prototype. Now let us try to understand this. We need to initialize the spin lock. Into logged state. No, unlogged state. Means when the spin lock is initialized, it is by default initially in the unlogged state. Okay. It must be initialized after cdev init and before cdev add. Okay, spin lock init, that takes pointer to a spin lock which you have declared inside struct dev. So it is a pointer to spin lock. Now something interesting. Let's go to Linux spinlock.h. Yes. Here, you see, spinlock init is a macro which is used to initialize your spin lock. After that, This is the macro in line number 334, spin lock in it, which we have used just now to initialize our spin lock. Then there are different ways of locking the spin lock and getting into the critical section. Okay, first is this line number 352. There are many ways, and we need some mention here, need some discussion here. How it work? Spin lock, locking the spin lock first of all. Locking the spin lock. Okay, it happens like this. First one is this wide spin lock. There are three things that needs mention here. First is interruption. There are two types of interrupts: software interrupts plus hardware interrupts. Preemption and atomic. Atomic means about scheduler. Now, software and hardware interrupts are disabled on all cores of CPU. Okay. Preemption happens on all cores of CPU. Scheduler disabled on all cores of CPU means everything in the multi-core system stops. If the spin lock is not able to get you spin lock and not able to get into the critical region, then interrupts, preemption and atomic scheduler, everything will be disabled on all cores of the CPU. Very dangerous. Okay, then you have this one. Here again you have three things: interrupts, preemption and atomicity. Interrupts, preemption and atomicity. Now only software interrupts are considered here, not hardware. Disabled on all cores. No hardware interrupts are disabled. Preemption disabled on all cores. Atomicity means scheduler. Disabled on all cores. Okay, so this is how this BH version. See this BH? This is software. Okay, means we are considering only software interrupts to be enabled or disabled. Hardware interrupts are not disabled. Okay, so unfortunately I am out of time. Spinlock requires some time. It usually gets implemented in 2 sessions. So I'll continue my discussion on Spinlocks, how the locking happens. Then towards the end of it, I'll implement Spinlocks and demonstrate it to you. Then you will also have to implement. Okay. I hope you are able to understand whatever I explained to you now. I'll continue my discussion in the next class. Don't miss it. Thank you.